Mathematics course, Chapter 1, Functions. A function is a rule that assigns to each element from one set exactly one element from another set. This is the first set, which is called here D. And this is the second set. So for each element like A in the first set, we assign exactly one element, which is denoted as f of A in the second set. Let me give you an example. Consider this function, y equals f of x, which is defined, and that's the rule actually, by x squared plus 3. When you give x one value, like x equals 1, you can get y, which is 4, etc. So for every value for x, we can find or we can assign exactly one value or one element for y. X actually is called the independent variable, where we can choose it any number, and y is called the dependent variable. Actually, the first set is called the domain. So this set is called the domain, and this set is called the range. So note that what do you mean by domain and range? The domain, it is the set of all possible values of the independent variable, while the domain is the set of all possible values of the dependent variable. In this lecture, we are going to discuss some familiar functions, some known functions, where we are going to use them in our course. The first one is the linear function. The linear function, which is a representation for a straight line. A linear function takes this form, y equals f of x, where f of x equals mx plus b. M actually is the slope of the straight line. And for every value for x, we can find a value for y. For every element x, we can find an element y in the domain. This is an example of a linear function, y equals 3x minus 2, or f of x equals 3x minus 2. This represents a straight line. Clearly, the domain here is the set of all real numbers, R. Another function is the quadratic function. Why we call it quadratic function? It takes this form actually. We call it quadratic because we have ax squared. We have like 3x squared, 5x squared. And we have to restrict ourselves that a is non-zero, because if a is 0, then you don't have this term and the function will be a linear function. This is an example of a quadratic function, y equals x squared minus 4. Actually, this is called a parabola. Another example is this one, y equals minus 3x squared minus 2x plus 1. This is also a parabola. When the coefficient of x squared is negative, as you can see from the graph here, the parabola opens downwards, while when the coefficient of x squared is positive, the parabola opens upwards. Next, we define what do you mean by a polynomial function. A polynomial function is any function of that form, where you can have the power of x is possibly x to the power 3, you can have x to the power 3, x to the power 8, x to any power. If you have only x squared, this is called the quadratic function. If you have only x, that's the highest power of x, we call it linear function. Okay, actually an, which is the coefficient of the highest power of x, it's called the leading coefficient, the leading coefficient. If you divide a polynomial over another polynomial, you can get a new function. This new function is called a rational function. Rational function because it looks like a rational number. You have a division. But when we have a division, the denominator cannot be 0. The polynomial that is down here in the denominator cannot be 0. That's an example of a rational function where you have y equals 1 over x, and that's the graph of this function. So as you see in this lecture, we are displaying like a catalog of functions, all possible functions that we can deal with. The next function is what we call it exponential function. Exponential function with base a. It is defined this way. If you have a to the power x, what is a? Just a real number. But a has to be positive and it cannot be 1. A to the power x, so 2 to the power x, 3 to the power x, 5 to the power x, 8 to the power x. Okay? This is what we call it exponential function with the base a. That's an example. Y equals 2 to the power x. This is an exponential function, and that is its graph. This is another example. If you consider y equals 2 to the power minus x, it is an exponential function. And note that when we speak about exponential function, we have x or minus x in the power. X is in the power. Note that 2 to the power x, the function is increasing, you see, but while 2 to the power minus x, the function is decreasing. It's going down here. Once we defined this exponential function, there is a very famous number that's denoted by e, and we call it the natural number e. Actually, for this amount, 1 plus 1 over m to the power m, when m becomes larger and larger, this amount is going to get closer and closer to a certain number, which we call it e. So e for you is just this number, approximately this number. We can actually call it is 2.71. So e, the natural number, is just 2.71. But that is the definition of the natural number e. So if you look at the graph of the function y equals e to the power x, this is exponential function where we are going to call it natural exponential function. Natural exponential function. Since e is between 2 and 3, this function will be between 2 to the power x and 3 to the power x. Note that all these exponential functions are increasing functions. Now it's time to define logarithm. We have defined the exponential function. We are going to define y is the logarithm of x with base a if a to the power y equals x. Since we are using exponential function, the base has to be positive and cannot be 1. But also there is another restriction. To define the logarithmic function, or the logarithm here, the value should be positive. So log x is only defined when x is positive, is only defined when a is positive, and cannot be 1. This is called the logarithm of x. We can take this function y and we define what we call it logarithmic function. So log x with the base a, we call it logarithmic function. Logarithmic function. What is the graph of this logarithmic function looks like? I will tell you the graph, but first, if you consider e instead of a, if you take the natural number e, if you take the logarithmic function log x with the base e, this will be denoted by len x. and it is called the natural logarithmic function. So what is len x? Len x is the logarithmic function log x, but with base e. The graph of this function looks like this one. There are some properties of natural logarithmic functions. And actually, they are properties for any logarithmic functions, but we are going to use natural logarithmic functions a lot. The first one, if you have len of a product xy, it is len first plus len second. If you have len of a division x over y, it is len of the top minus len of the bottom. If you have len x to a power b, so you can take the power down and you get b len x. Finally, if you have len 1 over x, it is minus len x. The natural number e has some easy properties. If you take len of e, you will find that it is equal to 1. If you take len of 1, it will be equal to 0. You can get that one, you can check that by using your calculator. E and len, you can find them in your calculator, and you can use your calculator easily with len and e. The exponential function y equals e to the power x, the natural exponential function, and the natural logarithmic function y equals len x, they are actually symmetric about this straight line. You see, they look like mirror image to each other around this straight line y equals x. So that's why these two functions, natural logarithmic function and the natural exponential function, are inverses to each other. What do you mean inverses? That means if you take len first and then you take e, you will get x. So again, if you take len x, then you take e of len x, you will get x. And also, if you take e first, e to the power x, then len of that, you will get x. So it looks like len and e, they cancel each other. Len e to the power x will be x. E len x will be x. So len, the logarithmic function len, and the exponential function e are inverses to each other. One last type of functions, trigonometric functions, and we are familiar with these functions: sine function, cosine function, and the tangent function. If you have a right-angled triangle, what do you mean by sine theta? It is opposite over hypotenuse. Cosine theta, it is adjacent over hypotenuse. Tan theta, opposite over adjacent. Opposite over adjacent. And of course, we can define cosecant theta, secant theta, and cotan theta, and they are the reciprocals of sine, cosine, and tan respectively. This is the graph of the first trigonometric function. That's sine, that's the graph of cosine, and that's the graph of tan. And as you see, they are periodical functions. They are repeatedly every period. Actually, the period for sine and the cosine is 2 pi. One example in this lecture: how we find the domain of a function. To find the domain of a function, we actually have two rules. I will explain these two rules by that example. The first function, consider this function. Find the domain. Root f of x equals root x plus 2. I have a square root. We know that we cannot have square root of a negative number. So x plus 2 must be positive. So let us repeat this. The square root of a negative number is not defined. We cannot define the square root of a negative number. So x plus 2 must be greater than or equals 0. But this means x must be greater than or equal to minus 2. You take minus 2 to the right side. So these are the possible values for x. These are the possible values for x. Whenever x greater than or equal to minus 2. So that is the domain. Remember, the domain is the possible values for x. So it will be this interval from minus 2 to infinity. Note that this squared bracket means that the interval is a closed interval, while the round bracket here means the interval is an open interval from that side. The second example, find the domain of this function. For this function, we have a denominator, x squared minus x. And we know that the numerator cannot be 0. We cannot divide by 0. Division by 0 is not allowed. So I have to exclude the values that will make the denominator equal 0. To find these values, we factorize the denominator. So again, factorize the denominator. X squared minus x. We can take x common factor. So it will be x times x minus 1. I have x here, so x cannot be 0. I have x minus 1, so x cannot be 1. So again, what is the rule? The rule is that division by 0 is not allowed. Division by 0 is not allowed. So g of x is not defined when x is equal to 0 or x equals 1. You find the values which make the denominator equals 0. So in that case, what is the domain of this function g of x? The domain is the set of all possible values of x. So we can write it this way: all x such that x cannot be 0 and x cannot be 1. Or we can write it in interval notation this way: all values between minus infinity and 0, all values between 0 and 1, all values between 1 and infinity, and take their union, and note that 0 and 1 are not included here in this interval. To summarize, to find the domain of a function, we have two rules. If you have a square root, the square root of a negative number cannot be defined. So what is beneath the square root should be positive. The second rule, division by 0 is not allowed. So if you have a denominator, the denominator cannot be 0.